I will show my screen here. All right. So today we're going to discuss how to choose the right control system for your facility. We're going to cover various factors, looking at PLCs and DCS, and basically how we go about doing our work when we suggest to customers what kind of systems they should use in their plant. So my agenda for this presentation, more or less here, is first, I'd like to cover a bit of a history lesson on where the DCS and the PLCs come from. Kind of look at these two competing technologies and where they come from, kind of like looking at their DNA if you want. How did they come about? We're going to cover looking at a typical PLC architecture, typical DCS architecture. So we'll travel back in time a little bit, maybe 10, 20, 25 years, and look at how things used to be and where these technologies come from. We'll look at pros and cons of PLCs factors, DCS factors. We'll look at briefly some cost comparisons on PLCs and DCS, and there'll be a brief question period at the end. I'm told we also will answer all these questions in written format, and you can get an email back with all the questions answered, not just the one we're covering in this presentation. Okay, so what is a PLC? What is a PLC? Let's dive right in. The letters stand for Programmable Logic Controller. And essentially, a PLC is just a high-speed microprocessor device that controls multiple IOs, inputs and outputs. So there may be switches and knobs as an input, and usually coils and relays and so on for the output. Now, PLCs were initially just a replacement for, again, relays and timers. It started back in the automotive industry, where everything was done with, again, very tangible stuff, coils, relays, switches, and knobs. And in order to automate these, the PLC was basically invented. They are typically programmed using ladder logic, and their HMI, well, if you just look at a PLC by itself, there is no HMI. It's just a box, a controller, and it connects to its IO and it controls, it does its own thing. By itself, the PLC does not have an HMI. The first HMIs that came out were basically just the lights, the buttons, and the switches on the panels. There was no need for screens and monitors and keyboards. Operators just used whatever was on the wall. As the PLCs evolved, in the ladder logic, things like features like one-shot logic were incorporated. Multiple function mathematic functions were introduced in the ladder logic as well. So then the PLCs could do even more and more functions. And eventually complex analog and output signals were introduced as well. And floating math. And nowadays you even have a lot of PID algorithms. You can do PID controls directly in a PLC. The initial focus for the PLCs was the automotive industry, as I said earlier. It was used to control and automate the production chains for cars. The concept of tag names is relatively recent as well in PLCs, right? Because initially there was no need for tags. Everything was done with coils and contacts. And again, as I said, there was a panel somewhere on the wall with metal knobs and giant light bulbs and indicators. And things like tags were a foreign concept. They were never actually needed for a PLC. And the HMI was just, again, just buttons and lights, and the tag names, if there was anything, was all written right on the panel above each light. There was never a need to search for a tag name in a system. There was no such concept. You just walked up to the board, the panel, and you looked at what you needed to look at, and that was it. And also the concept of programming versus configuring, that the PLCs are programmed usually. We talk about programming a PLC. You program it in ladder logic or any other language that you may need. There's not much configuration per se to do one on a PLC. Now, PLC systems are typically sourced from multiple vendors. There's a vendor for the PLC itself. There's usually a separate vendor for your HMI. And if there's any communication requirements, those are, again, third-party vendors that will come in and supply these.